Let us review the important concepts and formulae in circles. So first we have the various equations. If the center is at the origin and the radius is a units, then the equation of the circle is given by x squared plus y squared equals a squared. If the center is at the point h comma k and the radius is a, then this is the equation of the circle. In general, the equation of the circle is written down in this form, and the center of the circle is the point minus g comma minus f, and the radius is given by the square root of g squared plus f squared minus c. Most questions on circles are done by starting from the general equation. So the diameter form of the equation of a circle is given by this one. x1 comma y1 is one end of the diameter and x2 comma y2 is the other end of the same diameter. The intercepts that a circle makes on the two axes also have formula. So this is the formula for the intercept made on the x-axis. Obviously g squared should be greater than or equal to c. The formula for the intercept made on the y-axis is given by 2 times the square root of h squared minus c. Now if g squared is equal to c, then the circle would touch the x-axis, and if h squared is equal to c, then the circle would touch the y-axis. There are useful forms to start with. So if the circle is supposed to touch the x-axis, then we can start with this equation for the equation of the circle. If it is supposed to touch the y-axis, then we can start with this one. If it touches both the axes, then we start with this formula. Now we know what the concept of a tangent is for a circle. So if we have to write down the equation of the tangent at the point whose coordinates are x1 comma y1, then this would be the formula for the tangent. And this is for the circle whose equation is x squared plus y squared equals a squared. For the general equation, the equation of the tangent would be given by this expression. So the rule is to replace x squared with x1, y squared with y1, 2x with x plus x1, and 2y with y plus y1. There is a condition for tangency which is very important. So if this is a line y equals mx plus c, and this is the equation of this circle, then the line would be a tangent to this circle under this condition. C squared is equal to a squared times 1 plus m squared. In general, if you have to use the condition for tangency, we say that the distance of the center of the circle from the given line should be equal to the radius of the circle. The length of the tangent has a formula, and this is the formula. So we have to just replace x with x1 and y with y1 in the equation of the circle, after ensuring that the coefficient of x squared and y squared is 1. Now two circles can intersect, or they might touch externally or internally, or they may not intersect at all. So we have various conditions for those things to happen. So if C1 C2 is equal to R1 plus R2, then the two circles touch externally. C1 is the center of the first circle, C2 is the center of the second circle, and R1 and R2 are the radii of the two circles. So C1 C2 represents the distance between the centers of the two circles. We will assume that R1 is greater than R2. Now if C1 C2 is equal to R1 minus R2, then the two circles touch, but they touch internally. If C1 C2 is greater than R1 plus R2, then there is no intersection and one circle is completely outside the other circle. If C1 C2 is less than R1 minus R2, then again there is no intersection, but one circle is completely inside the other circle. So depending on the relative position of two circles, we can have different number of common tangents. So if C1 C2 is greater than R1 plus R2, that means one circle is completely outside the other circle and they do not intersect, the number of common tangents would be 4 in this case. If C1, C2 is exactly equal to R1 plus R2, then the two circles touch externally and there would be 3 common tangents. If C1, C2 is less than R1 plus R2 and also greater than R1 minus R2, then there would be 2 common tangents. If C1, C2 is equal to magnitude of R1 minus R2, there would be exactly 1 common tangent, and this happens when one circle is touching the other circle internally. If C1, C2 is less than the magnitude of R1 minus R2, then one circle is completely inside the other circle and it's not even touching the circumference, and therefore there would be 0 common tangents. There is also a useful parametric form for the equation of a circle. So if we have the circle in this form, then we can write it down in the parametric form like this: x equals h plus a cos theta and y equals k plus a sin theta. So theta here is the parameter.